Okay, can everyone hear me, or do I need to turn the mic up a bit? Up, okay. So I'm very well mic'd up, because as you saw on the front page as you walked in, we're actually going to be videoing the class this quarter, and they're going to appear on YouTube later in the afternoon after each lecture. So that's hopefully a good thing for you all, because it means that if you have an emergency and have to disappear somewhere, you can catch up pretty easily. And if you want to study again for the midterm, or my strange accent means that you have no idea what I'm talking about, you can at least go back and listen in and hear again. Okay, so I just wanted to let you know that that was happening, and so the back of your head might appear on YouTube, which I know you're all horrified about, but as long as the hair's okay, it should be all right. Okay. So welcome to Introduction to Earth System Science, ESS 1. I'm really, really delighted to have so many people here. I'm obviously excited because this is my field and the professor has to be excited. But I obviously love Earth System Science. I think it's a really important thing for everyone in the university and everyone in the world to know about, because so many of the problems that I like to say our generation, but really it's your generation now, is going to face is to do with population growth, it's to do with environmental issues. And so I think it's a really great thing in general for people to become a little bit more educated about the world in general. Okay, so just a bit of information. I'm Dr. Julie Ferguson. You are very welcome to call me Julie. I called all my college professors by their first name, so it feels really odd to me not to do that. Otherwise, Dr. Ferguson or Professor Ferguson is fine. My email's up there. If you are going to email me, please do include ESS 1 in the title. This isn't the only class I'm teaching this quarter, and so you're much likely to get a faster response if you do include ESS 1, so I know who you are and where you are. Okay? My office hours, I have lots of them because there are lots of you. So Monday 2 to 3, Tuesday 3:30 to 4:30, Wednesday 9:30 to 10:30. And those will be in my office in Crowell Hall, which is way the other side of campus, but I have faith that you could find it. I also have an informal coffee hour where you're just welcome to come chat to me if you want at the Phoenix Food Court on campus here. I'll sit there and drink coffee, and if anyone shows up, we can have a chat. Okay. So, you are in an Earth System Science class, and hopefully that means that you've at least thought a little bit about what Earth System Science is. But just in case you don't have the faintest clue what you've signed up for, then this is Earth System Science. It's the approach that we use pretty successfully now, which is to say that we can't look at just the atmosphere in isolation, because things like the biosphere or the hydrosphere or the geosphere affect the atmosphere. And in the same way that we can't look at any of these 4 different spheres, we call them, independently, because they all interact with each other. And especially if we're going to start addressing some of the really important problems facing the world in the next 100 years, we really need to start thinking about how everything is really interacting. Okay, so we have the biosphere, which is basically everything that is living. We have the atmosphere, which is all the gases and particles that make up our air. We have the lithosphere, which is really the sort of solid part of the earth. It's the rock, it's sort of parts of the soils. And then we have the hydrosphere, which you can break down into so many different ways. It's sort of the oceans, it's fresh water, it's the big ice sheets. Anything that's composed of H2O really goes into the hydrosphere, with one exception, which is water vapor, which is a gas which is part of the atmosphere. So we have a little bit of a funny one there. And people argue about whether we should have a 5th sphere, which is the anthroposphere, which is basically us. Just like anthropology is the study of humans, we're having a huge, huge impact on the Earth right now. And so whether we get lumped into the biosphere or whether we become our own sphere, we really do need to think about the impact that we're having on the Earth. Okay, so what are some of the things that we're going to talk about this quarter? So we're going to do a bit of a whistle-stop tour through all the different spheres, which makes this one of the slightly more challenging of the general education ESS classes. But I think the nice thing is it really gives you a wonderful overview of just how interconnected the whole Earth is, and sort of you start seeing things in a very different way. So we're going to spend the first part of the quarter talking about the formation of the Earth and the geosphere in particular. And so we're going to talk about different rocks, but associated with that is the fun stuff like earthquakes and volcanoes and things like that. We're then going to continue and talk about the atmosphere. We're going to talk about why we always have such beautiful, amazing sunny weather down in Southern California, and what controls things like the position of deserts, why we get storms, and what sort of patterns we see. We're then going to move on to the hydrosphere. We're going to talk about ocean circulation. We're going to talk about ocean chemistry, and those are both questions that come into play when we're talking about climate and potential changes in the next 100 years or longer. And ice sheets as well, and sea ice and all sorts of fun stuff like that. We're going to talk about the biosphere, not so much as the Bio 93 and 94 type classes do, but we're really going to concentrate on the role of the biosphere and how it interacts with all of these different spheres, because obviously the biosphere is very important for things like atmospheric composition. It's also a really important force in sort of weathering, in breaking apart the geosphere as well. And then we're going to spend a bit of time at the end, a couple of weeks, talking about our impact on all of these different aspects of the Earth system. And in particular, we're going to spend a week talking about climate, how climate changes, why climate changes, and in particular, what we know about what has been happening in the last 50, 100 years, and what our sort of best scientific sort of estimates tell us about what might happen in the future as well. So there's a lot of stuff, okay? And hopefully it will be fun. There should be something there for everyone, but it does mean that you will have to keep up, because we will be skipping through fairly fast. Okay, so this is me in my favorite type of weather, which you don't get often down here. So I am from the UK, not Australia. I get that every year, okay? This is an English accent. I'm a lecturer in the Department of Earth System Science. My job is a bit different in that I tend to do a lot of the big general education classes. I teach 5 classes like this each year, so I teach things on the cryosphere, on ice. I'm going to be teaching oceanography next quarter. I'm going to be teaching the atmosphere in spring. So if you enjoy this, I'm hoping that you'll follow me. And I was delighted to see about 50 or 60 people on my roster from last quarter or the quarters before, so welcome back. I'm glad you decided to come back. But before that, and in my spare time, I do a little bit of research as well, and my particular type of research is in trying to reconstruct climate records for the past. And why do I bother spending my time doing that? Because if we're going to understand how climate might change in the future, or if we're going to understand what climate is doing now, we need to understand more about how it can change, why it can change, and also what sort of the natural variability is. How do we know that what's happening today is us compared to the natural system just sort of wobbling around? And so for that, we use things like corals or stalagmites from caves, or deep sea sediments, stuff like that. That's what I would tend to do. So I wanted to show you a little bit about who else is in the class, because it's a ginormous class. It can feel really sort of impersonal. Okay, so 50% sophomores, that's who we have. We only have a few freshmen that managed to sneak in as people drop the class, and then we have a few juniors and seniors as well. Okay, and unlike some of the intro chemistry and physics and everything else, the vast majority of people in this room are nothing to do with science. And so I wanted to make that point to begin with, okay? So you are not alone if you're sat here thinking that you're terrified and that you hate science and math. Probably the people around you are the same. There are 20 Earth System Science majors in the room. If you can find them, then they would be helpful, I'm sure. But it might be a bit of a challenge. We also have a handful of biosci, a few other physical science people, and some engineers. Oh, there you go, they're up there. But we have a small army of political science majors. We have a small army of business economic majors. And so the class will be pitched that way. So we're not assuming any really previous knowledge. But I do want to encourage you to ask questions. If I'm going too fast, then please do put your hand up and ask me. Other people in the room will be very happy that you did, because you're the one brave one, okay? Especially if I use words that aren't familiar, which is something that perhaps scientists get a bit bad at doing. Okay, so please do, I encourage you to ask questions and branch off in tangents. Okay, but that really tells me nothing about you. Okay? So I'm hoping that some of you will take the time to do this, which is your first assignment, and it's not graded, no credit, unfortunately. But just let me know a little bit about you, what your name is, sort of if this is the first ESS class you've taken, why are you taking this class? You had a whole raft of options. Why is this the one that you chose? Tell me at least one thing that you would like to learn more about, so that I can hopefully target the class to people's interests. And then also tell me the most remote or the furthest place from home you've ever been, and tell me why you liked it. Okay, so, and these notes are all on the internet as well, so you can access them if I move on. Okay, so this is our class website. Hopefully a lot of you have found it already. That should be the first place you go to find information. I am happy to answer questions. However, if the question that I'm answering could easily have been found in 2 minutes on the website, I tend to get a little bit angry. And that's because there are 400 of you. If it took me 1 minute each day to answer 400 emails, I'd spend 7 hours simply answering emails. So I do encourage you to ask me questions if you can't find the information, but please do check here first. And it has most of the things that you would want to know. So it has a syllabus, it has the schedule with all of the different discussion topics, as well as the different lectures. It also has all the exam dates, so please do look at those now and mark your calendar. Lecture notes will always be posted on the class website by 5 p.m. the day before class, so you can print them and bring them with you if you choose. I do encourage you to do that. Laptops are great, but they're such a temptation. I know this from my personal experience. You go, oh, I'll just check my email for a second, and then you get distracted. So do think about not using your computer. There's also going to be other resources on there, so answers to questions from class, practice exam questions, answers to midterms, extra credit type stuff, which I'll announce as we go along. So please do use that. I know a number of you have found it. They're also on the schedule, it has some reading assignments from the Blue Planet textbook, which is actually a really nice book. It's pricey if you get the hardback new edition that the bookstore is selling, but there are cheaper ebook options, paperback options, something like that online, and hopefully you got an email from me about that. So do take a look at the readings I assign you, please. Sometimes I'll get you to really look at the readings ahead of time, and that means that we can more quickly skip to the interesting stuff, and that will happen in one of the lectures next week. Other times, I'll just say, please do the reading associated with this topic. It'll help you fill any gaps in your knowledge. Okay, so what is actually, this is always the boring bit, but we'll try and go through it quickly, but it's important that everyone knows. Discussions will be 9% of your grade. You only have to go to 3 of the 10. I'm hoping that you'll go to more anyway, but 3 is a minimum. And I'm doing something a little bit different this year in that the TAs last year said the same 5 people turned up, sat in a room, and we didn't really do much. So I want to make it slightly more exciting. I want you to get you outside, because this is an Earth System Science class, okay? So a lot of these discussions, the majority of it, will involve going outside. For example, there'll be a geology scavenger hunt around campus. We will triangulate an earthquake on the lawn. I'll just get you outside observing next week, thinking about the different parts of the Earth system and how they interact, because everyone walks around with their phone like this, and no one actually looks at the world anymore, okay? So they should be simple, and most of the discussion time, maybe 30 minutes, will be to do those there'll be group activities, and then the remaining time will be, can you hear me? Does it keep fading out? The remaining time will be for you guys to ask questions of the TAs and do other things. Does that sound okay? Yep, should be fun. There'll also be online quizzes. The reason I have these weekly quizzes is that this class moves pretty fast. If you're not understanding something, it's really very important for you to realize that as much as it is for me to realize that early on. It also, I have a problem with willpower and studying, and so it's a way of encouraging you to look at your notes and look at the information. You will be allowed 3 attempts at each quiz, okay? I don't tell you which ones you got wrong or right, but you are allowed to go through and think, oh, hang on, I only got 6 out of 10. What am I not certain about? And have another go at answering. And I'll take the best of those 3 attempts, okay? Concept map, I'll come back to that in more detail another time, but what I really want to stress in this course, which is different from, say, if you take oceanography in winter or the atmosphere in spring, is the interconnectedness of the system. How really all of those different spheres feed into each other, and a change in one affects everything else. And so I'm going to get you to sort of represent this in like one of those, people call it different things, maybe a spider diagram or a concept map, or a mind map, something like that. And I'll bring in a couple of examples to show you. Don't be terrified. It's meant to be something that just gets you to think. It's a really good way of studying the material before the final. And so we'll talk more about that as the quarter progresses. And then, of course, there's the exams. Please do note the date. There will be no early exams, and make-up exams will only be given to real emergencies, just because there's too many of us to do anything else. Okay? And lastly, participation. Everyone got their iClickers? Okay? So you can earn full participation credit by using your iClicker in 22 out of the 27 lectures that we're going to have this quarter. So if you don't have it today, it's not the end of the world, but these things are really helpful. First of all, it keeps you awake. Secondly, it allows me to work out if you're getting what I'm telling you. Okay? And it allows you to understand whether you're getting what I'm telling me. It allows you to practice and review stuff that we've done in the lecture, and it also gets you to sort of talk to your neighbors and start thinking more critically about the material. Okay? Our first, oh yes, and you don't have to get the right answer. Okay? It's more just for understanding. And so this is why I do this. In the average class, this is the heart rate of the average student in a lecture. Okay? And you can see everyone arrives having run across campus at minute 0, and there may be sort of 85, 90 beats per minute. Within about 20 minutes, everyone's comatose. They're fast asleep, they're not learning anything, okay? And that's sort of uninterrupted lecture. So I'm going to try and space out these iClicker questions, get you interested and excited and waking up again, okay? So that's why we're doing these. So my first question for you, as a practice, is if you had to do one of the following, which would you do? Eat a deep-fried locust, have to stand up and answer a question on the board in front of 350 people, walk on a tightrope over the Grand Canyon with safety rope, or sit in a room filled with live but harmless spiders. Okay. Yeah. Can you keep quiet for a second? We have a question. You sure it was at the participation? I'll go back and check that, and I'll let you know. Okay. Has everyone had a chance to answer who would like to answer? Okay. So let's see what people in the room would rather do. Oh, we have a bit of a shift. Most people would rather stand up in front of 350 people. Well, that's encouraging. Okay. So that's an idea of the type of thing that we do. So hopefully for the freshmen in the room, you have a slightly better idea of how this works. Okay. So let me go back, because apparently my maths doesn't quite add up. Okay, 4 plus 16 makes 20, plus 9 makes 29, plus 5 makes 34, plus 16 makes... You're right. Let me go back and check my maths. Sorry about that. It's a good start, isn't it? Okay. Here's the schedule. It's up there just to show you. We've already talked about this, so I don't want to dwell on it. But please do go and check for the different discussion topics. Pick the ones that you're interested in. Look at when the reading assignments are due and what topics we're going to be looking at. Okay. So, academic honesty. We are not idiots. Okay? People cheat every quarter, and it really annoys us, and it's completely unnecessary, and it's really unfair to everyone in the class. So please don't do it. It really is very disrespectful, and it also doesn't really help you out in any way. Okay? Most of the activities, apart from the exams this year, are more participation or group activities, so there really is no need for it, so please don't do it. But cheating in this class and any other class on campus also includes using someone else's iClicker for them, okay? And we catch people every year doing this. The TAs will be around the room, so please don't do it. If you get caught, you'll lose all participation points for the quarter. If you miss that one lecture, is it really going to make that big a difference to your grade? So please don't do it. It's very unfair to everyone else. Other expectations, turn off your cell phones. Most people are good at this. Listen when someone else asks a question. Participate when asked. We'll be doing little group activities. Please do get involved in those and keep going. Don't talk. This is a big room. I know it can be tempting if you want to say something to someone, but please keep it. You're paying a lot to be here, okay? And people are behind you and around you are not going to be able to follow what's going on if you're talking over them. The TAs have my permission to ask you to leave if you're talking too much and being disruptive to the class, and I will also stop and ask you to be quiet. So just don't do it, okay? I can be mean when I'm angry. Okay, so just be courteous to each other. Laptops and note-taking, as I said, incomplete notes will be available from 5 p.m. So I don't like to give the game away and give you the iClicker answers or questions beforehand. So I'm going to then post updated lecture notes after the class, and that will contain all of the things like the iClicker questions and answers for you to double check after class. Do seriously consider not using your laptop. It does create a barrier between you and me. Do review your notes within 24 hours. It really helps you cement the material into your head. And people do this every year. They come to me after the first midterm and they're, I studied really hard and I don't understand what I'm doing wrong. I sort of read everything, and I said, well, what did you do after you read everything? I read it again. And I said, okay, well, what did you do after that? Well, I read it again. And that's not necessarily going to help you. If you don't get it the first 3 times you read it, you're probably not going to get it after that. Think about using more sort of active techniques, so things like draw diagrams and pin them on the wall. I always tell people to do this. This is what I did during my exams. A lot of Earth System Science is visual stuff. You can write 3 pages and you could represent the same thing in 1 diagram. Okay, so do think about doing that instead of just highlighting or reading stuff over. Always bring pen and paper to class as well, because we will be using that. Okay, we have a class Facebook group. It's not compulsory. You can join it if you want. I'll post stuff related to what we've been learning about. There's always tons of new stuff and news articles and videos and images circling around the internet, which are fun to share. You're also welcome to post anything that's relevant to the class as well. You can use it to organize study groups or anything like that, or ask me questions. It's worth saying that I have enough of a life that I'm not going to be stalking you on Facebook and looking at your profiles. But now might be a good time to think about how much information you might want to share with someone who is teaching you Earth System Science. Okay, so think about your privacy settings as well. Any questions so far? Good. All the boring stuff is done. Okay. I want to know what you know. Okay. So iClicker's out. Tell me, how old is the Earth? And you are allowed to talk to your neighbors if you want to consult. Okay, 5 more seconds. Okay, let's see what people think. Ooh, that's good, and it's even the right answer, which is even better, okay? So we have an awful lot of agreement about that one, and that's good. Everyone should have learned this sort of stuff at school, which is encouraging. Okay, now the questions get a little bit more tricky. Okay, we experience seasons, not so much in South California, but elsewhere in the world, because A, the sun gets closer to the sun, the Earth gets closer to the sun in summer and further away in winter, or B, the Earth orbits the sun and its axis is tilted, or C, you just don't know. Remember, you get points for any answer, so don't hold back if you're really not quite certain. Okay, 5 more seconds. Vote if you haven't. Okay. So B, oh, you guys are so good. Okay, so B is the correct answer, which is because the Earth's axis is tilted. So it's not because we move any closer or further away from the sun, it's our tilt that causes our seasons. It's a good sign. Okay, the sky is blue because it reflects the color of the sea. Air molecules scatter blue wavelengths of light, or nitrogen gas is ever so slightly blue. Okay, couple more seconds. You can probably tell by the way I wrote the question, right? But yes, you are right, that it is nothing to do with the color of the sea, okay? It's actually the air molecules in our atmosphere are scattering blue wavelengths of light preferentially, and we're going to talk more about this when we come back to talk about the atmosphere. So you guys are doing well so far. It's cool. Okay. So most of the oxygen in the atmosphere is generated by burning fossil fuels, the terrestrial biosphere, so all the biosphere on land, or the marine biosphere, all the biology in the oceans. Okay, let's take a look. Okay, so I've managed to catch you for the first time. Okay, these are the misconceptions that people often have coming into Earth system science. So the first 3 were pretty good, but I've caught you. Okay, the terrestrial biosphere is important, but it's the marine biosphere. All of those tiny bits of algae living in the ocean, or the unicellular organisms in the ocean, that actually generate over 50% of the oxygen in our atmosphere. Okay? And so we always forget about that because we think about ginormous trees, but actually the ocean biosphere is much more important for the oxygen in the atmosphere. Okay. How about this one? The ozone hole is related to global warming. Okay? I've caught you again. Okay? So the ozone hole was generated because we were using CFCs as coolants and things like refrigerators and as aerosol cans. But actually, that isn't anything to do with the extra heat that we're trapping near the Earth's surface today, which is mainly due to things like methane, carbon dioxide, okay? 2 entirely separate problems. And the ozone hole is something that UCI had a really important role in, if you've listened to the college tours probably. But the chemistry department and Sherry Rowland there really had a very important role in identifying how CFCs could destroy ozone. But we've fixed it. We came up with international agreements. We've restricted the use of CFCs, and actually the ozone hole will start to repair itself, and it'll probably be back to normal by maybe 2070, 2075. But global warming and climate change is something entirely different, and we still haven't found ways of addressing that, okay? So there's another one. And last one, okay, the main reason that sea level has risen over the last 100 years or so is the melting of glaciers and ice sheets, The warming of ocean water or more rainfall over land? What do you think? Okay. So let's see how we did on the last one. I caught you again. Okay. So we're even now. It's 3-3. Then we don't have a tiebreaker, unfortunately. But the main reason that we're concerned about sea level right now is due to thermal expansion, it's called, which is that as water warms up, it expands a little bit. And if you're warming 4 kilometers or something of the water column in the oceans, then you're going to see a significant increase in the height of sea level. So definitely glaciers and ice sheets are melting and contributing to sea level rise, but they're not the main reason that we're seeing the change right now, okay? So I wanted to show you these because this is one of the things about Earth system science. We live in the world, we experience it. And that's great because it means that you can hopefully connect what we're learning in class to things that you're experiencing every day. But there are some things that you think you know that may not be entirely correct, okay? And hopefully I'll be able to address some of those as we move through the quarter. Okay, good. So quickly, this is a science class, but we're really going to be focusing on big picture stuff. And I thought before we really start talking about the big picture stuff, we need to really cover the scientific method, okay? Because a lot of the words that we use to describe things like theory are used in sort of English in different ways, okay? So this is our scientific method. We make observations, or we investigate something and do experiments, and we get results. And from those, we form a hypothesis, I can't say it right now, a hypothesis to explain our observations or investigations. And we have to test that hypothesis. A hypothesis is something that really has to be testable to be part of the scientific method, okay? And if that hypothesis is if that test that we do supports that hypothesis, great. We pass that on, other people do separate experiments and check and confirm our results and do their own independent tests. And if they continue to support this hypothesis, then we can move on and that might become a theory. However, you can't just make it up. If you're testing your hypothesis and you don't get the answer you like, then you have to scrap that hypothesis and come up with another one, okay? And this is really what the scientific method is about, is that you really do have to sort of use your hypothesis to explain the observations you're seeing, okay? So when we say something is a theory, if we use that in general conversation, then what we mean is we think this might be the thing. A scientific theory is something that we actually have a fair amount of confidence in. It actually has passed a number of tests. So a theory is a scientific idea that has passed numerous tests and failed none. And if you want to promote a theory to something even better, then that theory could become a law or principle. So a theory that has been really decisively demonstrated and no exceptions have been found. Okay? And so you're all probably familiar from school with some, but I thought I'd ask a quick question. So which of the below is a law rather than a theory? Which of those do you think we're more certain about? Okay? Okay, we've hit 200, so let's see. Yep, absolutely. So you do win today after all. Okay, so gravity, absolutely. We have not found any exceptions to the fact that if I drop something heavy, it will fall to the ground. Okay, we haven't found any exceptions to that theory, and so it really has become a law of gravitation. Whereas the Big Bang theory is still very much a theory, and evolution is still very much a theory. It's passed a number of hypotheses. It's the best thing we have right now, but for various reasons, such as the timescales involved, it's not rigorous enough to be called a law yet. It's not that we don't think it's true, it's just that it's probably very difficult to test and become that certain about it. Okay, so I wanted to show you a quick example that's very relevant to something that appeared in the news today. So our observation that we're going to come back to in the last week of our classes is that the average temperature of the Earth has been getting hotter over the last century. So the black line on that lower graph there shows the observations, our change in temperature. And it's the temperature anomaly, so it's like the difference from the average. And so you can see that especially since 1960, we've been seeing an increase in global temperature. So what about our hypothesis? We could say that our hypothesis is that natural changes are responsible for that change in global temperature. So natural things that affect the temperature of the Earth could involve solar variability. It could involve things like volcanic eruptions that put lots of ash into the atmosphere, which block incoming radiation. Okay? And that's fine, but if we run our climate models with just those factors, you can see all those blue squiggly lines are what we get. And you can see that it does a reasonable job maybe up to maybe 1970, 1980, but after that, the observations and our models really diverge. So our hypothesis that we can explain all of that change in temperature using just natural variability is not true. We have to throw away our hypothesis and come up with another one. And unsurprisingly, our new hypothesis is that we need both anthropogenic, so man-made or human influences, as well as those natural forcings. So we need to take into account things like atmospheric carbon dioxide increases, atmospheric methane increases, land use changes, so building structures or deforestation, things like that. And you can see that in the top graph, again, we have our black line shows the temperature change, and those yellow lines now show our models, including both the natural variability, but also those human changes as well. And you can see that now, so far, our hypothesis is holding, okay, that we can only explain those temperature changes that we've seen in the last, especially 30 years, with both natural and human causes, okay? And so far, this is the best hypothesis we have. But we're constantly gathering new information because this is an evolving problem. This is something that is happening now. And so as we gather new information, we're continuing to test that hypothesis. And as we prove or disprove that hypothesis, we adapt. That's the scientific method. And so when people talk they're 100% certain in something, not true at all. Okay. Let's take something that we're pretty certain about. How certain do you think, in percentage-wise, how certain do you think we are that smoking causes cancer? Someone want to be brave and give me a number? It's quite high, yeah. 100%? Not 100%, because we can never be 100%. So down a little bit from that, what do you think? Up from 80. I think I heard it over here, 95%, okay? We're 95% that smoking, sure that, or certain that smoking causes cancer, okay? And that's probably as pretty good as we're going to get because we're complicated organisms. It's not an easy system to look at and analyze, and so that's probably as good as we're ever going to get with that. It doesn't mean that we're not certain about it. It just means that there's always a level of uncertainty, and this is where scientists, I think, get off from the general public a little bit, is in that when we talk about uncertainty, especially at things like 95% certain, people don't necessarily understand what we're talking about. Why is this important? Because today is an exciting day for climate scientists, and therefore you too, because you are honorary people for this quarter, okay? Which is that today there's the announcement that we are now 95% certain that humans have caused the warming that we've seen in the last sort of 30, 40 years, okay? And again, if you think about how complicated the climate system is, that's pretty amazing that we can be that certain about it. And again, it's probably as good as we're going to get, and we might see little incremental changes, but we're really, really certain about this. And this is what was released earlier this morning, overnight, from Sweden, and it's the Intergovernmental Panel on Climate Change. Every 6 or 7 years, they release a report with the most up-to-date information, and this is the physical science stuff, the stuff I like, and they release the summary, which is only 36 pages, so anyone can go and read it, and the website's there, and over the next year, larger parts of this report are going to be released, and this is pretty important stuff. Okay, so it's very exciting, believe me, and we're getting even more certain about this. Okay, so on Monday we're going to talk about systems and feedbacks and the snowball Earth. Okay, thank you.